Imagine gazing up at the night sky. Thousands of years ago, ancient civilizations, like the Egyptians and Greeks, saw a universe much different than ours. They believed Earth was the center of everything. The sun, moon, and stars were thought to revolve around our planet. The Egyptians saw the sky as a celestial dome. It stretched over Earth, holding the stars in place. The sun god Ra sailed across this dome each day, bringing light and warmth. The Greeks developed sophisticated geocentric models. Ptolemy, a Greek astronomer, created a model that lasted for centuries. His model placed Earth at the center. The sun, moon, planets, and stars were all thought to move in perfect circles around us. These early models reflected the limited understanding of the universe at the time. However, they laid the groundwork for future discoveries. These discoveries would forever change our place in the cosmos. The 16th century brought a revolutionary shift in our understanding of the universe. Nicolaus Copernicus, a Polish astronomer, challenged the long-held geocentric view. He proposed a radical idea. The sun, not Earth, was the center of the solar system. Copernicus's heliocentric model placed the sun at the center. The planets, including Earth, orbited the sun in circular paths. This model elegantly explained the observed motions of the planets. It also challenged the prevailing religious and philosophical beliefs of the time. The Copernican revolution was a gradual but profound shift in scientific thought. It expanded our understanding of the universe and our place within it. The universe was no longer seen as a small Earth-centered realm. It was becoming a much larger and more complex system. In the 17th century, a new tool revolutionized astronomy: the telescope. Galileo Galilei, an Italian astronomer, was among the first to use the telescope for astronomical observations. His discoveries would further expand our cosmic horizons. Galileo observed mountains on the moon, spots on the sun, and moons orbiting Jupiter. He also made a groundbreaking observation about the stars. Through his telescope, Galileo saw that the Milky Way, a faint band of light across the sky, was actually made up of countless individual stars. This discovery led to a profound realization. The stars were not just points of light, they were distant suns, perhaps like our own. The universe was not just bigger than previously thought, it was filled with an unimaginable number of stars, each potentially hosting its own planetary systems. As astronomers continued to study the stars, they began to map the structure of our own galaxy, the Milky Way. William Herschel, a British astronomer, made significant contributions to this endeavor in the late 18th century. Herschel meticulously counted stars in different regions of the sky. He observed that the stars were not evenly distributed. Instead, they seemed to be concentrated in a flattened, disc-like structure. He also observed that our sun was not at the center of this disc. Herschel's observations led to a new understanding of our place in the cosmos. We were no longer at the center of the universe, or even the center of our own galaxy. We were on a planet orbiting an average star, located in the outskirts of a vast swirling galaxy of stars. Section 5. Beyond the Milky Way, Hubble's universe of galaxies. In the early 20th century, the universe would expand once again, this time on an unimaginable scale. Edwin Hubble, an American astronomer, made a groundbreaking discovery that would forever change our view of the cosmos. Hubble was studying distant, fuzzy patches of light called nebulae. Using the powerful Hooker telescope at Mount Wilson Observatory, he was able to resolve individual stars within these nebulae. To his astonishment, he discovered that some of these nebulae were not gas clouds within our own galaxy, but were, in fact, entire galaxies themselves. This discovery meant that our Milky Way galaxy was just one of many billions of galaxies scattered throughout the vast expanse of space. The universe was far larger than anyone had ever imagined. It was a universe teeming with galaxies, each containing billions or even trillions of stars. Section 6. The universe in motion, evidence of expansion. Hubble's discoveries didn't stop there. He continued to study the light from distant galaxies, and he noticed something peculiar. The light from these galaxies was stretched. Its wavelength shifted towards the red end of the spectrum. This phenomenon, known as redshift, indicated that the galaxies were moving away from us. Moreover, Hubble observed that the farther away a galaxy was, the faster it seemed to be receding. This relationship between distance and velocity became known as Hubble's law. It provided the first observational evidence that the universe was not static, as previously believed, but was expanding. The expanding universe implied that the universe was once much smaller and denser than it is today. This realization laid the groundwork for the Big Bang theory, which proposes that the universe originated from an extremely hot and dense state billions of years ago. Section 7. Echoes of the Big Bang, the Cosmic Microwave Background. In 1964, two astronomers, Arno Penzias and Robert Wilson, made an accidental discovery that would provide further support for the Big Bang theory. They were using a sensitive antenna at Bell Telephone Laboratories to study radio waves from space. To their surprise, they detected a faint, persistent hum of microwave radiation coming from all directions in the sky. This radiation, known as the Cosmic Microwave Background, or CMB, is the afterglow of the Big Bang. It is the faint echo of the intense heat and energy present in the early universe. The CMB provides a snapshot of the universe as it was just 380,000 years after the Big Bang. The discovery of the CMB was a major triumph for cosmology. It provided strong evidence for the Big Bang theory and gave scientists a powerful tool to study the early universe and its evolution. Section 8. The Accelerating Universe, Dark Energy's Enigmatic Force. In the late 1990s, astronomers made another startling discovery. They were studying distant supernovae, the explosive deaths of massive stars. These supernovae served as standard candles, objects of known brightness that could be used to measure cosmic distances. To their surprise, the astronomers found that these distant supernovae were fainter than expected. This meant that they were farther away than predicted by a universe expanding at a constant rate. The universe was not just expanding, it was expanding at an accelerating rate. This discovery implied the existence of a mysterious force counteracting gravity, pushing the universe apart at an ever-increasing speed. Scientists called this enigmatic force dark energy. The nature and properties of dark energy remain one of the biggest mysteries in modern cosmology. Section 9. Unraveling the Cosmic Tapestry, Ongoing Discoveries and Mysteries. From the ancient belief in an Earth-centered universe to the discovery of the accelerating expansion of the cosmos, our understanding of the universe has undergone a profound transformation. We now know that we live in a vast and ancient universe, teeming with billions of galaxies, each containing billions of stars. We have uncovered evidence of the Big Bang, the event that marked the beginning of our universe. We have discovered the cosmic microwave background, the faint afterglow of the Big Bang, which provides a glimpse into the universe's infancy. However, for all that we have learned, many mysteries remain. The nature of dark energy, the enigmatic force driving the accelerating expansion of the universe, remains elusive. We are still searching for dark matter, an invisible form of matter thought to make up a significant portion of the universe's mass. The quest to understand the universe is an ongoing journey of discovery. With each new observation and technological advancement, we peel back another layer of the cosmic onion, revealing more wonders and deeper mysteries. The universe continues to beckon, inviting us to explore its vast